Hi everyone, my name is Yuvarani Thorisingam from University of Putra, Malaysia. I would like to present the topic on argumentative approach to derivative function based on principal component analysis. The co-author of this topic is Dr. Muhammad Shafi Mustafa. The overview of my presentation will be start with the introduction, followed by literature review, the methodology, results and discussion, and last but not least the conclusion reference. The derivative function approach is commonly used in industry to tackle multiple response optimization problem. In general, the problem is generalized in multiple response optimization is the determination of set of variables that is simultaneously optimize the multiple correlated quality characteristics. So usually the variation present in the data will be ignored by most of the researchers during the multiple response optimization problem. Thus, to rectify this problem, an argumentative approach to derivative function and principal component analysis is used to reduce the variation among the responses, mainly on the multiple responses. For the literature review, the derivative function is introduced by Harrington in 1965. In 1980, Deringer and Surich modified the Harrington's model to obtain three flexible derivative functions, which is the larger the better, nominal the better, and the third one is the smaller the better. In 1996, Castillo et al. They proposed a gradient-based optimization by modifying the model of Deringer and Surich. In 2012, Chen et al. Used the smaller the better model from Deringer and Surich to minimize the prediction variation. However, the proposed method of Chen et al. Ignores the variability in each of the predicted responses. For the derivative function, transform each of the y predicted response to an individual derivative function where the derivative function need to be from 0 to 1. So in 1965, Harrington transformed the y predicted to derivative function using the exponential function, which have two transformations which have one-sided and two-sided. The difference between both is the negative exponential and the positive exponential. Overall derivative function is calculated based on the geometric function. The Deringer-Surich model is modified from Harrington's model and classified as a three types, as I mentioned in the introduction part. So the larger the better will achieve the maximized target value, the nominal method will attain the target value, and the smaller the better will have the minimized value. Chen et al. In 2012 used the smaller the better model from Deringer and Surich to calculate the derivative function by transforming it to the standard deviation as shown in these equations. PCA was first introduced by Pearson in 1901 and developed by Hotelling in 1933. The PCA main function is to reduce the dimensionality while preserving as much as of the randomness in the high dimensional space as possible. So the PCA is generated as the equation shown in this slide. So the PC1, PC2, PC3 is the principal component, whereas the W is the weight which will be set by the experimenter. Since the function of the principal constant is to reduce the variation, so the first principle will have the most variance in the data, which will be followed by the second principle, third principle, and so on. So the ignorance of variation and correlation in multiple responses of optimization allowed us to use the PCA model into the Chen et al. Model to minimize the variation in their model. We used the data from Hugh et al. 2008. They conducted an experiment using the microwave assisted extraction model. they have a 4 variables with 3 responses. So the target response of the y1 until y3 is set to the range of 93 and under according to the experimenter, and we also set the weight of the experimenter to take 0.9 based on the optimal solution. Okay, but this is the diagram that shows that the ds and the ds lambda, which is a derivative function, lambda versus the lambda graph. From here we can see when the lambda is 0.9, the value of z is approaching larger than 1 at lambda 1. So this indicates the standard deviation of y obtained from our argumentative approach are smaller. In order to us to find the PCA, we use the eigenvalues and eigenvectors to find for the each principal components. And once we get this result, we input the results in our proposed method with the PCA. So here we have compared our method with 2 other methods from the previous researchers, which is Arrington's and Chen argumented approach. From here we can see we have successfully minimized the standard deviations of the proposed model, and also we can see the 90% prediction interval is also smaller compared to Chen and Harrington's model. So for the conclusion, reduce the dimension of highly correlated data is very important by remaining the quality characteristic. So it also produces a better performance of multiple optimization with the proposed model with the PCA method. Hence, we achieve the goal of optimization multiple response with a minor variation. These are the references. Thank you.